there's really two areas of leadership, right? There's the technical leadership, and then there's the management. But in either one, lead by example. I'm not going to ask somebody to do something that if I wouldn't be willing to do it myself.
Hello and welcome to the Being an Engineer podcast. Today, we have the pleasure of speaking with Stephen B. Johnson, a seasoned electrical engineer whose career spans from military service in the United States Marine Corps to roles in embedded systems, network automation, and telecommunications. With a bachelor's degree in electrical engineering from Purdue University, Stephen has worked with industry leaders like Raytheon, Emerson Electric, and TDS Telecom. His passion for automation and innovation is evident in both his professional projects and personal endeavors, such as developing a fully automated sprinkler system and enhancing home security systems. Stephen, thank you so much for joining us today, and welcome to the podcast.
Thanks for having me.
So this was kind of a fun story of how we met. I always talk a little bit about the wave.engineer in our podcast. And Stephen has recently been contributing a lot of content on the Wave. He's got some really cool posts about personal automation projects that he's worked on, and we'll talk a little bit about those today. And I found his content so interesting and intriguing that I asked if he'd be willing to be a guest on the podcast, and he graciously agreed to do so. So thank you for being here again, Stephen. First question, same one I ask everyone. What made you decide to become an engineer?
Okay, so my path isn't as straightforward as most. I grew up in a very small town in Indiana. When I was about 9 or 10 years old, my grandparents were visiting from California, and my grandfather just happened to be a mechanical engineer in the aerospace industry. And I was doodling like cars or planes or something. And he looked at me, he's like, you should think about being an engineer. And I was like, okay, I had no idea what that was at the time because there was no such thing in my hometown. And then a few years later, somehow I got a hold of a TI 99-4A computer, and I was teaching myself how to program. And they came back to town, and I was showing him what I was doing. And he's like, you should be an electrical engineer. And I was like, and that is what planted the seed right there.
And what happened after that? I mean, did you start learning about what an electrical engineer is? And were you doing any of your own projects when you were younger before, formal training, education?
There was not much. There were no resources around. I would pop in the Radio Shack occasionally to be in awe of what was there. But,
Right.
But there was no buying a kit for anything. It just didn't exist.
Was there something, maybe it was even during college, but at what point did you know, yes, I've made the right decision. Electrical engineering is the right path for me? So
after I had that plan in my head, I was like, and I still continue to teach myself how to program. My mother, I would see her doing payroll week after week with this calculator that had paper rolling out. So I took on the endeavor of writing a payroll program. I was probably 13 years old.
Wow, that's no small endeavor, especially for a 13-year-old.
Yes, in BASIC, writing it in BASIC as well.
Yeah. Given the tools that were available then.
So I was fairly naive because I had no idea what the U.S. tax structure was like. I was doomed. I was just too naive. And then my mother, there was just no way she was going to break her habit of using that old calculator.
Yeah. Well, what do they say? Shoot for the stars, land on the moon, right?
Yeah. So there really wasn't much else driving me toward electrical engineering other than that seeds have been planted. And I kind of liked writing programs and seeing what I could do. And then the other obstacle I had to overcome was I had to figure out how I was going to get to college and pay for it. Because my parents did not go to college. My father died when I was 9 years old. And my mother's business was failing when I was in high school. So I kind of knew I had to figure it out. It's just another problem to solve, right?
Yeah, that sounds like a difficult place to be in. What did you do? How did you figure it out?
Well, when I was 16 years old, I enlisted in the Marine Corps, and I wasn't like the biggest person. I wasn't like physically. I was small, but one of the things I spoke to the recruiter, and I was pretty determined. I was like, okay, I could do this, and and I get the GI Bill, and then the recruiter asked me, he's like, what would you want to do? I took the test, and he basically said, what do you want to do? And I was like, I'd like to work on aircraft. And his face lit up because his background was working on helicopters.
Oh, nice. Okay.
So he kind of helped me, guide me into, I went to airframes in the Marine Corps. I worked on the F-18s.
How cool. That must have been a dream.
I mean, that was really cool. I mean,
yeah.
And the thing about a Marine Corps squadron is they're very small. It's a small group of misfits, really. I mean, it's just crazy. And you get to work on every aspect of the plane. Even though I was airframes, I was out there helping them drop power plants, avionics, whatever. Just because it's a very cohesive group.
Now, you say a group of misfits, and I know that you're saying that lovingly and affectionately. I'd love to hear you talk a little bit more about that. What was the group like?
It's just a group from all aspects, all areas coming together, and you could just achieve so much. One of our sayings was, we've done so little, we've done so much with so little for so long, we can do practically anything with nothing.
I love that. What do you think it was about either the culture or the environment or maybe the time? I don't know, just lack of bureaucracy in a good way. What was it that made your group so effective, so able to do so much with so little?
Well, we do. I mean, it's just everybody had this drive and we knew we had to get things done. Like all the maintenance on aircraft occurs at night, so the plane can be ready in the morning, and nobody would leave the hangar until everybody was done. Wow. So that that was a little motivation there too. But
yeah.
Even our pilots were our officers in our squadron, and my first lieutenant, he was a very squared away individual, and the other pilots would kind of pick on him. But he actually went off to become a space shuttle pilot. So it's just, you have to have a lot of drive, and that just emanated all throughout the squadron. I mean, it's a very good environment.
Group of really high performing individuals.
Yes. Yeah.
Wow. It sounds like an amazing group to work with.
Yeah. And we all had fun too. I mean,
so you worked on some really cool things, right? Aircraft. You just mentioned, I think, missile and satellite systems for Raytheon.
Yes.
Some really cool stuff. What have been some of the most technically challenging projects, and how? This is a huge question, right? No way to answer with detail in 30, 40 minutes, but one or two of the most technically challenging problems, and how did you and your team go about solving those problems?
Well, at Raytheon, one of the primary projects I was on was the Patriot 2 missile. And specifically, the automated test equipment for the power supplies. So, I mean, that narrows the scope down a little bit. One of the challenges that we had to overcome was, and I didn't know this at first, I'm fresh out of school. I show up there, and I'm gung-ho to, get into designs, and we're trying to pull together the requirements, really. In doing so, I learned that a sister division in Raytheon had the previous contract. So they sent me over to this other sister company, naive, straight out of school, thinking everybody's going to help me. I get there, and I find out that the division I was with won the contract over this division, and they had all the drawings, the bill of materials, everything. And they sent me into this place where I was like, ooh. I was trying to read, I could read the room, and I was like, this isn't, I just had to try to get whatever information I could and get back. And yeah, that was a challenge there.
Was it more like of an interpersonal challenge, like trying to figure out who was in charge of what and how to deal with the different personalities?
Total personality. And it's like I encroached on their domain.
Oh, okay.
So
how did you deal with that? I mean, did you find a solution that worked?
Well, I got what information I could, and I went back, and some of the project manager I was working for had to step in and kind of help get spore information. And then from that point, it was kind of like a sustaining engineering problem, because the designs were done like a decade prior. And I'm looking at the bill of material, and I'm like, okay, I need these devices, and 50% of them are obsolete. So now I'm like, okay, are we going to redesign these power supplies? Well, the answer was, no, that's not planned. I'm like, okay. The devices are obsolete. You can't buy them. Okay. So that was a challenge.
Yeah.
And they were actually looking at could we fab some of these? I'm like, oh, that'd be so expensive. So I was in the middle of that. Another thing that came up was for all these programmable devices, and there are thousands of them, and they'd have to be programmed, and we had to get a programmer. And I was working with the field application engineer from the little programmer, and she's like, yeah, these are obsolete. The device can't program these. And I was working with her trying to get the list of what, narrowed down. And then I hear that each device, they wanted to put the program for the device on a floppy, a 3.5 inch floppy drive, each program. Now there were thousands of these. I was like, no way. I'm like, if somebody sent me 1,000 floppy drives, I would be so upset. So CD writers were available then, just barely, but they were there. I'm like, we're going to burn these on a CD. They're like, what if they lose a CD? I was like, we'll burn 2 or 3. It doesn't matter.
Nice.
And
yeah.
So finally, I got people to buy into that. I was like, oh, there's a logistic nightmare we avoided. Because, so I got that. About at the same time there, I was also dealing with a satellite. It's actually in orbit, and I got this engineering change order. I almost thought it was a joke, because I was like,
it's already in orbit. What do you want me to change?
Yes. They're like, you need
strap on your spacesuit.
Yeah, you need to review this engineering change order. I'm like, it's in orbit. I'm like, if I approve it, is the thing going to change? No. If I don't approve it, it doesn't matter. I'm like, what's the point? So that kind of drove me a little batty there. But about the same time, I got contacted from Raytheon Corporation here in Madison, Wisconsin. They were following up on my resume that I'd sent them from Purdue. And so I was like, I was in Boston with Raytheon, and Boston really wasn't my cup of tea. So I was like, Raytheon. I was like, I had never heard of them other than I sent my resume apparently. And I had a friend from Purdue who was going to grad school at MIT. So I drove down there, and I was like, we went to the library, and I'm like, I need to find information on VME computer boards. Anything I can get, just so I can get prepped, because I was going to fly to Madison for an interview. And so I wasn't finding anything. I'm like, okay, here I am at MIT's library. I can't find anything on this. I'm like, what am I going to find? So I end up, I stopped at some bookstore, and I found a book on microcontrollers. I think it was some Barnes & Noble somewhere. And I opened it up, and I'm reading through it. The book actually referenced Huracan Corporation.
Oh, no way.
I was like,
it's like it was meant to be.
I'm like, this is unbelievable, because the internet was so infant then, you couldn't find anything. And so here I have this book. I'm like, okay, I'm reading about microcontrollers, Huracan Corporation, VME bus. So I flew in for the interview, and I get to Madison, Wisconsin, which I'd never been here before. I get in, I go to the interviews, and they give me exams, like hardware and software exams. I'm like, going through them. I'm like, okay. Met everybody in the company. It was a really small company at the time. Probably 80 engineers total. And we had the manufacturing and design in the same building. So the interview went good, and they wanted me to be a support engineer. So I was like, okay. And everybody would be supported would just be like engineers from companies, engineers from Lockheed, Raytheon, Lucent, Nortel, Sienna, just this engineer to engineer support, basically. I was like, okay, that's pretty cool. I could deal with that. And so I interviewed, went back. They made me an offer, and I was like, oh, I'll take that. I'll go back to the Midwest. So I showed up,
and the rest
and
is history.
Became a support engineer for open systems / embedded systems with real-time operating systems.
How have the tools changed over the years? I'm pretty familiar with how tools for mechanical engineers have changed, CAD and 3D printing, things like that, but not familiar with how tools for electrical engineers, software engineers have changed over the years. I mean, you talked about BASIC, right, back when you were younger.
Oh, yeah.
What have been some of the monumental changes in tools that allow engineers like you to do your job?
For embedded systems, some of the boards we had, frequencies were pretty decent. So you had to have scopes that had sampling rates that were substantial. And then you also had buses, so you had to be able to analyze a bus. So that was the main factor right there. I mean, it was like, since we did the manufacturing of our boards, we also had functional test software that would be running on the boards, and we'd put them into a burn-in where we'd ramp up the heat, and that would really shake out any weak link in the designs. If you start seeing memory errors with temperature. Yeah.
Any other tools that come to mind that you have now that you didn't have 30 years ago that are just game changers for what you do?
Today, I mean, we use a lot of off-the-shelf servers at TDS. But for me, I just have my little scope on my desk, which is perfect for me.
Yeah, great.
I'm not, it's not anything too sophisticated here.
All right. Well, I'm going to take a short break here and share with the listeners that the Being an Engineer podcast is brought to you by Pipeline Design and Engineering, where we don't design pipelines, but we do help companies develop advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services. Learn more at teampipeline.us. The podcast is also sponsored by The Wave, an online platform of free tools, education, and community for engineers. Learn more at thewave.engineer. Not just learn more, but go check out some of Stephen's cool posts that he's done there. Really interesting stuff with some of his personal projects. And maybe let's get into some of that right now. So, Stephen, you've posted a few things. There was an automated sprinkler system. You had we'll just call it a middle of the night nightlight for men. There was another one in there that is escaping me right now, but where does your inspiration come for some of these personal projects?
So, as I mentioned, I was at Huracan Corporation, and I was a support engineer, and I became a field application engineer. And one of the skills that I really seemed to be natural at was I could identify problems, concise problems that need solved. My personal projects are extension of that. We bought our house here 10 years ago, and the sprinkler controller was a little microcontroller-based thing, and we have 15 zones. To make a change, you'd have to stand out there and turn this little dial and push buttons, and turn the dial and push buttons.
I despise those things. Just the worst designed product ever, and almost all of them are equally bad.
Yes, I concur. And then I'd be driving home from work. I was actually in the office then, so I'd be driving home, and it may be raining out. I pull my driveway, and I see sprinklers running. It drove me absolutely insane. So I decided to. I was like, I'm just going to design a controller. I had no idea how it worked, the current system, and then I had figured it out. I was like, okay. At the time, Raspberry Pis were out, and we have all this GPIO. Perfect. I can deal with this. I figured out that the sprinkler controller really just controls 24-volt AC going the solenoids out in the yard in these little, basically valves. I was like, oh, so perfect. All I have to do is control this 24-volt AC using GPIO through a relay. But I don't want to touch this. I want this to be fully automated. So I started writing the code. I started writing in Python 3. Python 3 had just been released. I was like, okay, I'd used Python 2.7 before. Python 3 had it's a little bit different, not too much. But, okay, I'm going to force myself to use Python 3. And I created a zone class for each, which created an object for each zone so I could track statistics, like how long they ran, when it was going to run next. And then to determine when it was going to run, I was like, okay, how can I get the weather? I was like, there's some airports nearby. I was like, okay, they have weather stations, so I could query the National Weather Service, I could query an airport, and I could say, okay, they both indicate, one of them indicates rain, one doesn't, how much is it going to rain? So I could make decisions based on that. And you also get keep track of how much rain there was, and I could control the zone runtime. If it's been raining a lot, I just run the zone 5 minutes each. If it's been dry for a week, run it for 10, 15 minutes each. So I was like, okay, that's pretty good. But then I was like, okay, I want this to be more effective. So, and I don't want to see sprinklers running. So I calculated the sunrise every day, and I backed off from sunrise. So the last sprinkler finished at sunrise.
Oh, wow. That's great. I love it. And this is so indicative of how typical projects go, right? You start with something basic, and then you start layering on complexity and sophistication until you end up with that perfect system, just what you want.
Yes. And I was able to test it through the winter using a very quick prototype. I bought some little relay boards off of Amazon. They had 8 relays each, wired it all up, and you could hear the relays clicking. I was like, okay, my simulation seemed pretty legit. Oh, and I mentioned I was tracking the weather. I had the software running, and I had it sending me the decisions it was making every morning. I was like, is it going to run? Is it not going to run? I had it emailing me. We went to London for a week with my family. Now I'm getting all these emails of like, it's not going to run. Like, it's being delayed. It's not running. Come find out, we had a torrential rain in the area.
So it did what it was supposed to do.
It worked perfect. As a matter of fact, when we got back from London, we drove up. We couldn't even get to our house because the roads were flooded.
Wow.
So I was like, oh, my logic, that validated my logic in one of the most extreme scenarios.
That's awesome. How satisfying that must have been.
Yes, that was. I impressed myself.
Any projects coming up that you're excited about working on?
My security system. That was another thing that was here in the house when we bought it. All the sensors were here, and the prior owner had it, who was also a Purdue engineer. And I wasn't going to pay for the service. So I was like, oh, I'm not going to pay for that. And so you have these little panels by the door, and you have to push the buttons and to arm it, disarm it, whatever. I'm like, I don't want to do that either. So I used, I took down the controller they had, and I put up a Raspberry Pi Zero W, and I wired the wired sensors to it. And then I have other Raspberry Pis throughout the house. I call them the panel. So like when a door opens, there'll be one beep. When a door closes, two beeps. And if I have an LCD connected to it, they'll tell you the date and time and what door opened and closed.
Oh, cool. Okay. So
I'll mention I had 3 teenagers at the time as well. So that was very important.
Yes. I understand completely.
Then we had the wireless sensors through the house too. I was like, oh, how am I going to see these wireless sensors? I had no idea how they worked. So I got a software-defined radio, which basically plugs into your USB. And I plugged it into a Raspberry Pi and a little bit of C code. Somebody was gracious enough to have a library on GitHub called the RTL 422. Compiled it. It just runs and it reads that software-defined radio. And when it sees a message, it will output as JSON. I was like, oh, perfect. So as it sees messages, outputs, I would capture that JSON with my Python code. And now I could do all the logic. So the logic I have, system is armed all the time, but when doors open and close, after a certain time, between a certain window at night and morning, if a door opens, it sends me a push notification to my phone. I can also arm it to where it would always send me a push notification.
That's so funny. So you have effectively circumvented the subscription model that this security company has and just use their hardware with your own homegrown system.
That's correct. Yes.
That's awesome.
And it's been running now for 9 years.
Wow. Amazing. And you have complete control over it. You can, make whatever you want it to do.
As a matter of fact, I just extended it about a week ago. We have woodpeckers. They like to make holes in one corner of our house primarily. So I was like, and when I'm sitting here in the basement, I can't hear them very well. And they could be going nuts out there. So I got a piezo mic.
I think I see where this is going.
Ran it through an Arduino analog digital converter. And then I had to figure out how could I detect the pecking sound without getting the ambient noise, which I figured out. If I put it flush with the surface of like the window, it will pick up those vibrations. But my wife vacuumed the bedroom it's in, and it did not trigger that. So I'm like, nice. That is perfect.
Yeah.
So, and I tied that into my security system. So if a woodpecker is pecking and it detects it, it'll alert, and it'll beep my security system five beeps. And
is that enough to scare the woodpeckers away? Or do you have to go out there?
No, I have to go out there and chase them off.
So now we know what the next addition to your system is, right? Some kind of loudspeaker right in that area that blares at them and scares them away, so you don't have to go outside.
Yeah, that would be great. But if anybody's ever dealt with woodpeckers, they're the most ornery bird that you go out there and try to scare them, they'll stay on the wall, stay on the side of the house, and they'll just look at you. It's like it's like they taunt you. It's
Yeah.
incredible.
What are you going to do, bud?
Yeah.
Let's see it.
Yeah. So,
as you were talking about this, a question came to mind. You know, all these different programming languages, right? You talked about JSON and C and Python, different versions of Python. I know nothing about software or programming. So this is maybe an obvious answer to anyone who has even a little bit of experience with software. How do you know which language to use for which projects?
If you need something that's really fast, like C is a good go-to language. It's been around for a long time. It's you have to be a little careful because it will allow you to do things which are exactly desirable, and you can crash your program. C++, if you need something if you want to do more object-oriented type thing, that's a good option.
What would be an example of an object-oriented thing?
Where you could create a class. Like, for example, I created a class for my zones for my sprinkler controller. So each zone, I created one class, and I created 15 objects using the same class.
Okay.
So C++ would be a good option there. But really today, Python it's a Swiss Army knife of programming.
Is that your go-to these days?
Yes. It's very nice. Of course, you'll find people with different opinions all over the place, but
sure. Yeah.
But another thing that I find is the Python community is very cordial. I don't know how else to explain it, but some programming languages out there, you ask a question in a certain form, and you step back and just wait to be
berated.
Yes. The Python community is not like that at all. And
interesting.
It's a very, this is an interesting psychological phenomenon that somebody in psychology should really look at, because it is, I think it's just a side effect of the language being so nice. Interesting.
That is very interesting. Wow. All right. Well, you've done, obviously you have a plethora of technical experience and knowledge and understanding. You've also taken on some leadership roles in your career. What is some advice that you would give to younger engineers who want to kind of step into leadership roles?
So there's really two areas of leadership, right? There's the technical leadership, and then there's the management. But in either one, lead by example. I'm not going to ask somebody to do something that if I wouldn't be willing to do it myself, or at least help do it if they need it. For the technical leadership, keep an eye on new technologies, try out new things. I'm always trying something new. I have a server over here. I'll fire a virtual machine, try something out just to see, is this useful? Is it not? Even the Python stuff I did for my personal projects carried over to my work. Things I learned. You can always learn. Put yourself out there, learn, and the leadership roles just kind of roll in.
That was something else I was going to ask you about. I've heard about a few of your personal projects. I'm sure there are many more that you've done. So it seems to me like you spend a fair amount of time doing personal projects that are engineering related. To what degree has that helped your career?
I really do my personal projects to keep me more ingrained with my electronics engineering feelers. Sometimes at work, you start encroaching on the IT. You skip the atmosphere of the IT realm, and sometimes I need to get pulled back into that engineering domain. So that's what I like. I will never get pulled into the IT side. That's just not me. I'm an engineer first and foremost, and it may encompass there is a serious overlap in a lot of areas there.
What is one thing that you have done to accelerate the speed of engineering?
So let me relate this to a project. A few years ago, I got pulled into a cable TV platform. It was pretty much a mess, and they needed somebody who knew video and servers and could write some code to try to automate some things. So that's a pretty good fit for me. When I first got pulled in there, they gave me their master spreadsheet, which was like, oh no, there's no way this could be accurate because there are just too many moving parts. There's just no human that could keep this accurate. So I started collecting data from the equipment, and we started pulling it into a database, and we started mapping the content flows. And then once I collected all this data, some people in other adjacent teams are like, oh, you have accurate data. They would ask me for it. And I was like, okay, I will send this to you, whatever frequency you want, because I'm pulling this automatically. And I'm sending it to them. So they always have accurate data. So I'm not working from something that's totally irrelevant. And that alone has sped things up so much. And the number of man hours saved, I don't know how to calculate. It's just huge.
So you took a process that was being tracked manually in a spreadsheet, presumably not very well because there were so many moving parts associated with it. And you basically automated it. You started pulling data from the different pieces of equipment, feeding it into some central repository, doing an analysis, spitting out results. And that was kind of the process here.
Yes. And then one of my colleagues, which I worked with for many years, did the front end. So we exposed a web page for whoever wanted to use this data. And
beautiful.
It's just, it's still, this morning I got the email, it sent the email to our product management. So they have all the fresh lineups, so it's completely accurate.
Oh, I bet everyone loves that. What do you think the reason was they hadn't done that before?
I don't think there's a lot familiar with programming and being able to reverse engineer how to get this data from this equipment, because I call these my little minions that go out there and get this data. There's a lot of reverse engineering how I look at these GUIs and I was like, how's this GUI getting the data? And I'd figure it out and okay, I can get this data, but I'm getting it like 20 times faster.
Nice.
So it just worked out great.
Wow. Just didn't have the right skill sets before you came along, I guess.
Yes. And it's also, not only is it accurate data, it's kind of like automatic documentation. Which, again, documentation is something, it's the last thought in anybody's mind ever. But it's so crucial to have, good documentation. This web page, it shows you the channels. You click on it, it shows you the flow, where the content's sourcing from. It could be sourcing from Utah and going to New Mexico. It could be sourcing from Madison, Wisconsin, going to Colorado.
That's perfect because most engineers I know don't love doing documentation. But as you mentioned, it's really important. You need to have it. There's an engineer that I worked with a long time ago who used to say that the output of engineering is documentation. I thought that was a great catchphrase.
Yeah.
All right. Well, Stephen, thank you so much for being on the show today. This has been delightful hearing your stories and experiences. I think there's going to be a lot that people take from this. Before we sign off here, I wanted to try something a little bit different, recommended by a friend of mine. I'm going to read one of the, we get messages from listeners every now and then, and I'd love to hear more from our listeners. Frankly, we don't hear from listeners as much as I'd like. And I'd love to promote some more interaction between we here who produce the podcast and those of you wonderful listeners out there who consume it. So this one is from Nicolette Fornelis. I hope I pronounced that last name right. And Nicolette says, I recently came across your podcast and wanted to thank you for sharing industry insights from various perspectives. I recently graduated with a master's in bioengineering and felt a bit lost about how I would fit into the professional world. Your podcast truly opened my eyes to how impactful engineering can be. I would love to connect with you and learn more. Thanks again for the inspiration. Thank you so much, Nicolette, for the wonderful, heartwarming message. And of course, to all of the guests like Stephen and all the others that have been so generous in sharing their time and contributing to this body of knowledge here on the podcast. So if you're listening to this and you have something to say, maybe you'd like to suggest a guest, maybe you have recommendations for different things to try, topics you'd like to hear about, please send us a message. You can find me on LinkedIn and just message me directly on there. You can also find me on thewave.engineer. Send me a message there, and we would just absolutely love to hear from you. So with that, I guess we'll sign off now. Stephen, how can people connect with you?
LinkedIn is a perfect way to find me. Steve BJEE.
Perfect. And we'll include a link to your LinkedIn profile in the show notes here. All right. Well, Stephen, thank you again so much for being on the show. Really, really appreciate it.
Thanks, Aaron. I appreciate it, and I enjoy your podcast.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.